Hi, Jiaxing. Thanks for joining the call. My name is Lei, and today we're gonna discuss the video that Professor Shell shared to us. So I want to go through a quick recap of what's being discussed in the video. Okay. So the instructor in the video briefly goes through the definition of the pattern and microservice. So it's very similar to what we discussed in class. So pattern is software template or description to solve a problem that occurs in multiple instances. And microservice is an architectural style that structures the application as collection of small autonomous services. Basically, it's a small service communicate with each other. And then the instructor quickly goes through the principles of microservices, which is also similar to what we discussed in class, which are something like real-time load balancing, availability, isolation from failure, and scalability. So then the instructor mentioned some of the design patterns. The first one is the aggregator, which is the pattern that can collect related items of data and display them on the DRY principle, which is very beneficial if a server requests data from multiple services. So in these circumstances, we can use the aggregator to pack the data as an aggregation. And then the second design pattern is the API gateway. So I think in the video, the API gateway is the pattern that can convert the protocol request from one type to another. And I think this is pretty much the same thing as the broker patterns that we discussed in the class, right?
Yes, we discussed the broker pattern in our class, and I think it's related to maybe very similar to the API gateway pattern. And the broker pattern separates users of service from providers of service by inserting an intermediary, and it's called a broker. And when client needs a service, it requires broker via the service interface. The broker then forwards the client service to the request to the server, which process the request. The broker can be seen as an API gateway, which forwards the requests from clients and returns the response from the servers. And since the broker pattern also introduced client-side proxy and server-side proxy as the actual communication intermediary, it can add the API gateway there to transform requests and responses format if necessary. Yeah.
Thank you. So the third design pattern is a chain of responsibility. So I think it's very straightforward from the name. So chain of possibility can produce a single output, which is a combination of multiple chain output. So it uses synchronous HTTP request or respond or messaging. But I think the instructor also mentioned the client won't see any response until the response come back from the chain. So, Jiaxing, do you think it's similar to any patterns that we discussed in the class?
Yeah, I think it's very like the pipe and filter pattern we discussed in the class. So in pipe and filter pattern, data is transformed from a system's external inputs to a system's external input to its external output through a series of transformation performed by its filters connected by pipes, which is very likely a chain. And the final output is the last output on the chain or in the pipe. I think they are just using different names, but they are similarly the same thing. And pipes are the chains, and the filters are the data processors. But I think there's some difference in that in pipe and filter pattern, the components can execute in parallel. So it can be a topological graph structure rather than a linked list structure in the chain of responsibility pattern. Yeah.
Yeah, that makes sense. The next design pattern is a synchronous messaging, which from my understanding, it's so in this design pattern, all the services can communicate with each other, but they do not have to communicate with each other sequentially. I think this is similar to the service-oriented.
Yeah, I think in service-oriented architecture, it's more like that you can choose, or the developer can choose to use either the asynchronous way or the synchronous way. And if the service-oriented architecture using the asynchronous messaging to connect to each other, then it can be considered as asynchronous messaging pattern. Yeah.
Okay. The next one we have is the database. So the database can be per server or shared database. And I think it limited the number of servers that have access to the shared database. But in this in this pattern, the scaling can be a problem, right?
Yeah, I think so, and I think it's exactly the shared data pattern we have discussed in our class, just changing the name. So the communication between the data accessor is mediated by a shared data store, and control may be initiated by the data accessors or the data store, and the data is made persistent by the data store. So I think they are just the same concept as the database pattern, just using different names. Yeah.
Okay, yeah, yeah. A lot of them are similar, but with different names.
Yeah.
Yeah, the next one is event sourcing. From the definition from the video, it creates event regarding the changes in the application state. So event store listen to the state change and create event. Sorry, which may update the presentation layer.
Yes, I think this one is also very similar to the publish subscribe pattern we discussed in the class. So in publish subscribe pattern, the components publish and subscribe to events. When the event is announced by a component, the connector infrastructure dispatches event to all the registered subscribers. I think they are also the same thing, just we discussed before, and they both they have the listeners and the publishers, and they both emit or listen to events, and the listeners may update their states when receiving the events. So this, I think this the same idea like the event sourcing pattern. Yeah.
Gotcha. The next one, yeah, it's not very clear to me. It's called decomposition. So in the video, it says decomposition of application according to a subdomain of application business capability, strangler or vine pattern. I think we kind of discussed in the class too for this kind of pattern.
Yeah, I think the idea of the composition pattern is to divide the responsibilities into different components. So I think it's very common in the microservice design patterns, and I think something we discussed in our class, like the layer pattern or the model view controller pattern, they are they should be some specific of the decomposition pattern. The layer pattern and the model view controller pattern, both patterns decompose separate modules into different parts. The difference is how the modules are separated. So the layer pattern is separated by the core stack layers from top to bottom, and the model view controller MVC module is separated by functionality. Yeah. And Yeah, actually, I searched the patterns we discussed in the class, and I think there are some other patterns only mentioned in our class, such as the client-server pattern, the peer-to-peer pattern, the service-oriented architecture pattern, the map-reduce pattern, and the multi-tier pattern. Yeah, I think we have exceeded the time limit, so I'm going to dive into very details. And those patterns have been discussed in detail in our class, and so yeah, I'm going to skip this part.
Okay. Thank you.
Thank you.